Hey guys, so this video I really just want you to watch. I'm not going to give you homework on it. It's really to prepare for the next unit that we're going to be doing. These are some skills you need, but we're going to go super basic with it. So we are talking about, what are the perfect squares? So the perfect squares are, with 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. So these are all the numbers that are perfect squares. We know the square root of all these numbers, right? The square root of 49 is 7. 64, 81, 100, 121, 144, 169, 196, and 225. So these are all the perfect squares. They're called perfect squares because we know the actual square root of them. What does it mean to simplify a square root? So one thing we do with square roots is we simplify them. And that means that when you have the square root, there's not any perfect square underneath it. So, for example, it's kind of a weird definition. We're rewriting a square root, so there's no perfect square underneath it. So like, when you simplify the square root of 4, you just get 2. But let's say you have the square root of 12. The problem is 4 goes into 12. You can divide 12 by 4, and that's the issue. So when that happens, it's not simplified. So we're going to go through how to simplify something where this inside, which is called the radicand, if the radicand, the inside of the square root, has a perfect square that divides into it. We're going to go over how to simplify it. And it's pretty basic. Most students don't have too much trouble with this. All right, so 24. So now think about what your perfect squares are, right? On the side, 1, 4, 9, 16, 25, 36, 49, and so on. So think about which one of these numbers on the side that I listed goes into 24. So here's how I teach this. We are looking for all the multiples of 24. So what pairs of numbers multiply? Well, 1 times 24. Then I increase the 1. 2 times 12. And if you're not good at multiplication, just divide. So for 3, 24 divided by 3 is 8. 24 divided by 4 is 6. 24 divided by 5 is sadness. It's a decimal. So we're done with. And then 6 we already have. So we're going through and we're writing down that's every single pair that multiplies to 24. So now I'm going to go through and I'm going to look which of these numbers are in that list. Well, the 1 is in the list and the 4. So we want to use the biggest number, the biggest perfect square we see. So we're going to use the 4. So we're going to rewrite 24 as 4 times 6. Okay? So that's the square root of 4 times the square root of 6. But what's the square root of 4? The square root of 4 is 2. Do we know the square root of 6? No, so we rewrite it. And that is our simplified answer. Done. All right, number 2. So again, we're going to start by writing down every single pair of numbers that multiplies to 63. 1 times 63. Oopsies. Helps if I write the 6 in the number 63. So 1 times 63. 2 doesn't work, so I'm not writing that down. 3 times 21. 4. If you try to do 6 divided by 4, that doesn't work. 5 doesn't work. 6 doesn't work. 7 times 9. 8 doesn't work, and then we're back to 9. So that's every single pair. I'm going to look for my perfect squares. 1 is a perfect square, and 9 is a perfect square. So we're going to rewrite 63 as 7 times 9. So 7 times 9. I'm going to break that up. The square root of 7 times the square root of 9. I don't know the square root of 7, so I'm just going to rewrite it. I do know the square root of 9, though. The square root of 9 is 3. And then we don't like to leave the root looking like that, so we're just going to move the 3 in the front. And that's the answer. All right, I want you to pause your video and try this next one on your own. Now, this one tends to mess kids up a lot. So this is what happens. I'm going to show you the wrong thing, okay? So 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So those are all our pairs. Now, a lot of kids automatically will jump to 4 and 12. They're like, oh, 4. Okay. Square root of 4 times 12. Square root of 4 times the square root of 12. The square root of 4 is 2. Here's the problem, though. 12 is not simplified. There's another perfect square. So look in the list. What's a bigger perfect square other than 4? 16. So that's why you really want to look through the entire list. What is the biggest perfect square that goes in a 48? So instead, we're going to make this 3 times 16. Square root of 3, square root of 16. Again, I don't know. Always ask yourself, do I know the square root of this number? No. Do I know the square root of this number? Yes. And then put that in front. So 4 root 3 is the simplified answer. All right. Getting a little harder. So take a minute and simplify the 72. So 72 is 1 times 72. 2 times 36. This one has a lot. 3 times 24. 4 times 18. 6 times 12. And 8 times 9. Those are all the perfect squares. So now let's look for all of the numbers. So 1, 4, 9, and 36. So pick the biggest, 2 and 36. So 72, so don't forget that 7 out front. So we've got 2 times 36, root 2, root 36. So I have 7, we have root 2, the square root of 36 is 6. Now, when things are touching, but there's nothing between them, what does that mean? That means multiplying. So then we're going to take our 6 and our 7. Those are just going to be multiplied. So 42 root 2. All right. Pause the video and try number 5 on your own. All right. So 80. 1 times 80. 2 times 40. 3 doesn't work. 4 times 20. 5 times 16. 7 doesn't work. 8 times 10, 9 doesn't work, and 10 we already have. So again, our 1, I honestly don't even usually circle the 1 because it's silliness. 4 and 16, so negative 11, and we're making, this is 5 times 16. I don't know the square root of 5, so I'm going to rewrite it. I do know the square root of 16. The square root of 16 is 4. And these are all, there's the invisible multiplying there. So negative 44 root 5. All right, last page. So now here's a time when you could use this. Think back. We've done this a ton of times this year. Find the missing side of a right triangle. So what are we doing here? This is our Pythagorean theorem. A squared plus b squared equals c squared. Now, we've always put decimals, but the higher up in math you go, we tend to have, instead of using decimals, I'll have an exact answer. So a and b don't actually matter. Remember that. So I'm going to do x squared plus 10 squared equals 20 squared. X squared, 10 squared is 100. 20 squared is 400 minus 100. X squared equals 300. We're going to take the square root of both sides, x equals. So now, instead of putting the decimal, we're going to simplify the square root of 300. So think about what perfect squares go, or what numbers multiply to 300. So 1 times 300, 2 times 150, 3 times 100, 4 times 75, 5 times 60. Now, if you see it, stop. There is a perfect square that I already wrote. It's 100. So we can stop if you're really positive that that's the answer. So this one is the square root of 3 times 100. The square root of 3, square root of 100. So we end up getting the square root of 100 is 10 root 3. And that's your simplified answer. All right, last one. Pause the video and try this one on your own. 8 squared plus 12 squared equals x squared. So remember your C value for the Pythagorean theorems across from your right angle. 64 plus 144 equals x squared. So x squared equals, let's see, that's an 8, 208. Square root of both sides. I honestly don't know the answer of this off the top of my head, so let's do some math. Let's see. I'm going to come up here. 1 times 208, 2 times 104, 3, nope, 4 times 52, 5, 6, well 3 doesn't work, 6 doesn't work. Now the question is, does 16, yeah, 16 is going to be the answer. If you do 208 divided by 16, you get, this is 4 times, it's 16 times 13. So it's the square root of 16 times 13. Square root of 16, square root of 13, 4 root 13. And that's your answer. So this is where the square roots come into play when we don't want to simplify our square roots with something like Pythagorean theorem. All right, that's it. I'm going to put a homework up, but it is, I'm going to count it as extra credit. I really wanted you just to watch this video and see how simplifying works. All right, have a great weekend, guys.